For more complicated molecules, it's going to be difficult to generate the molecular orbitals by simple inspection. And so we have to use aspects of symmetry and group theory in order to construct the molecular orbitals and understand the nature of the shapes of the molecular orbitals for these types of molecules. And so this is the entire process, the full process for constructing these molecular orbital diagrams using group theory. And so the first thing we need to do is we need to determine the point group. And so the point group describes the collection of symmetry operations such as rotational axes, mirror planes, points of inversion that are characteristic of the molecule. The next thing we will do is we will set the principal rotation axis as the molecular z-axis for the purpose of determining the result of symmetry operations and downstream steps. The next thing we're going to do is we're going to construct reducible representations using symmetry operations on the basis set orbitals of the outer atoms, okay? And so the basis set of the outer atoms, as we've been doing before, right, is going to be atomic orbitals of these atoms. Number 4 is we're going to reduce the reducible representations to irreducible representations. And so what that allows us to do, once we have these irreducible representations, we then get information that allows us to construct from the basis set of the outer atoms, we can then construct the symmetry adapted linear combinations of atomic orbitals, or SALCs, that represent what we expect the central atom to interact with, or the wave function of the outer atoms within the compound. Number 5 is we're going to identify the irreducible representations of the central atom atomic orbitals. And then finally, once we have all this information, we can then generate the SALCs and combine with the central atom AOs and construct our molecular orbital diagram. In the videos that follow, we'll take this step by step to show the entire process.